Okay, so now our discussion has taken this form. Integrate, this is dy and divide by y minus 2 square and plus 9. Okay? And dy. Okay, right. Now, please check. This is which format? If you open the formula sheet, please. If you want, you can use substitution. Use substitution. But right now, because means what you take as u, by the way, y minus 2 derivative is dy. So there's no, anything different. So if the different differential is only dy, so no need for u. You can go without substitution. So please go back to the formula sheet. This is which format? Yes, 10, because it is constant square. 9 I can write 3 square. So this is a square plus u square. So this is basically 1 over a, right? 1 over a. What is my a? 3. So 1 over a, 1 over 3. Tangent inverse u. My u is y minus 2. Divide by a, which is basically 2. And plus 3 because this is indefinite. That's good answer. So this is the completing square procedure here. Okay? Let's take one more question from 7.7.
Doctor, how do you know if you're integrating inverse hyperbolic or inverse trigonometric or hyperbolic? Like, how do you know the difference?
This means you have formula sheet. You have to compare your questions and your formula format. For example, I will take one question. Just wait. Means this is inverse trigonometric function. Understand? Let's take one hyperbolic function. So, for example, I don't know means this is really works or not. Let's say we can take 72, please. 72. X times 4 plus x squared, please. Or 74 we can take as well. 70?
It's the same thing.
Yeah, same, both are same. Let's take 74, no problem. 74, please. 74. 1 to e is the limit. X and 1 plus n squared and squared. Okay. 74, please. 74. 7.7 section. Exercise number 7.7 and 74 plus we are talking about now. Integrate 1 to e. This is dx, and then we have x times 1 plus and the next it has square. Okay. So first of all, of course, means it's better to take substitution, please. What I take as u? Yes. So ln x is equal to u. Then we have dx over x is equal to du. Do you have dx over x in the question? Yes. Yes. Means dx over x is here. It means I can rewrite my question like that. So integrate, don't use limit now because it is u. Dx by x, how much? Du, and divide by square root of 1 plus u squared because my ln is u. Understand? Okay, now open the formula sheet. And please check this form. This format is matching what?
Sine inverse.
Is it?
Sine inverse and sine hyperbolic.
Sine?
Both the normal and the hyperbolic.
No, not at all. Not at all. Please check the inverse trigonometric function and then check the hyperbolic. It's not possible that it matches to
Sine hyperbolic.
sine inverse hyperbolic. Okay? In sine what is 1 minus? Sine inverse 7.6. It is 1 minus.
Oh, right.
Now be careful, please. Use the formula correctly, please. Okay. Yeah, it is sine inverse parabolic. So what is the way? What is that? Is it 1 over a or no? 1 over a is there? No. Okay. So highlight. It is directly sine inverse hyperbolic with u over a. Okay, u over a. What is your u? How much? Ln x. And divide by a. A is 1, so no need, please. Okay, no need. Don't forget, you have limits from where to where. 1 to e. Clear? Now substitute upper limit in the answer and minus lower limit in the answer. So sine inverse hyperbolic now. My upper limit is e, understand? And minus sine inverse hyperbolic, I have ln 1 because 1 is my lower limit, please. So ln e, how much? 1. So you have sine inverse hyperbolic 1 minus 0. Because ln 1 is 0 and sine function of 0 is 0. So please check, are you getting without decimal answer of sine inverse hyperbolic with 1?
Decimal.
It is decimal? Stop here. This is the answer, that's it.
It's similar to 7.6 question. Right?
Yes, but they have different rules. For example, look at here, let's say, if it is basically negative sign, now it is 7.6. Sine inverse trigonometric function. So you have to match the formula sheet with the question, please. Right now it's positive, now it is sine inverse. Okay?
In the exam, you will write.
Oh, no, the question comes in like that. Like that, you have formula sheet, you have to check what is the basically, which formula is fit in here. Okay. Right.
See, the question they say inverse hyperbolic function. That they want inverse hyperbolic function.
No, the thing is that they need two things, inverse answer and natural answer also. But we don't need natural, we only need the trigonometric, sorry, means the integration answer with inverse hyperbolic. That's it. Let's take one more question, please. 68. Please try this question 68. 0 to 1 by 3 is our limit. 6dx divided by 1 plus 9x squared square. Please try this. Then we start our next topic. 8.2. 68 question you can start.
8.1.
8.1 no. 8.1 is nothing, it's a repetition, review.
7.4, I think, right? 7.4.
No, you know. 1, 2, 3, 5, 6, 7. So please try the 68 question. 68.
Use substitution.
Come on, I already explained to you how you start the question, please. First of all, what do you take? We have to make x squared coefficient 1. Right now, x squared coefficient is 9. So first of all, please, you have, yes, means here, you have to take, here in this question, you have to take now, please, integrate 0 to 1 by 3, 6 dx divided by square root. Here, take a 9 as one factor. So you have 1 over 9 and plus x squared. Okay, so please, this we don't write 9 here. The coefficient of x squared must be 1.
When do I use the square?
Oh, if you don't have any perfect squares. In the last question, please, which answer here. Look at here. In this question, do you have any two terms as a square?
Because so I use it so I can get good terms.
So when we make the completing square, look at that. So you get two terms as a square.
So we can use the
Yes, so you have to use here completing square, please.
that's also maybe 7.2. one we also use.
Yeah, cat is for the to finding the inverse.
Inverse.
Yes.
We need to.
Yeah, exactly. It is to finding inverse because the square function inverse not possible directly. So you have to use converting square. Then you swap x to y to x. Then you are able to find inverse. Yeah, it's a different situation. But technique is yeah same. There they use converting square. Here also you are using converting square. Yes. Okay. So now what is 9 square root?
Now here we took 9 at the
Called factor because we have to make this coefficient of x square 1. So
It's 1/3 out, right?
so 9 squared is 3, it goes out now. 6 already have,
So
you
six
know,
over.
so 6 over 3 and square 0 to 1/3 I dx divided by 1/9 I can write as 1/3 and what? Square and plus x square. It has square root. Oh, I think the same. Again, repeating. A square plus u square root sine inverse hyperbolic. Okay, again, it is sine inverse hyperbolic. A square plus u square root. So this is gives you 2, and here you can use the formula now. So this is 2 times, which is with our case. Here, this is sine inverse hyperbolic x over a. A is 1/3.
So
It flips.
three.
It becomes 3 exactly, and it has limit from where to where. 0 to 1/3. Please put the upper limit in the answer and lower limit in the answer. Lower limit gives you what? 0. Because sine inverse hyperbolic of 0 is 0. So no need to waste time to put the lower limit because the lower limit is 0. Answer is 0. Only substitute 1/3, please. 1/3 makes it 1. Am I right? Yes. So the answer is only 2 sine inverse hyperbolic 1. Oh, same answer. Same answer even. Only with 2. 2 is the extra here. Yes. This answer, that's it. Get that point, please?
Victor,
Yes, please.
can you take this class as a revision?
We are taking many questions I have
You
done.
said after this you will enter the new topic.
Yeah, I have. Of course, we have no time. If you have some question, please let me know. Yes, please.
One question. After the exam, you will take class?
Yes, of course, we have class. First session, we have exam. 1:30 to 3 o'clock we exam. Okay? And then 3 we have break. 3:30 we come back to class. Please, question, yeah.
For example, in the last question, we used the substitution.
Okay, yes.
My problem is I don't know when I have to take a common factor or use the substitution.
See, actually, look at here. You can use substitution everywhere, no problem. You can use substitution in each and every question of integration. There is no harm. Sometimes to save time, for example, look at it. If we ask you, here, what you take as you, for example, here, please tell me.
That the dx over
Actually, maximum what you can take, you have to only take this one, is x as u. So what is x? If x is u, what is x is du? So it's not making any change. So if you avoid this substitution, no problem. So you can go directly.
it's already improved.
So for example, here you have, for example, square root of 3. And then you have x and it has square. Then in that case, you can make substitution because some constants there, it really make it change. Then it makes some change. Otherwise, no need. Oh yes, if you want to avoid confusion, it's fine. You can use substitution in all the questions. There's no harm. By the way, substitution is the best technique. But sometimes here, because the things are very easy, so we can avoid substitution, please. Otherwise, substitution is the best technique, please.
Victor, I have a question. From 7.6.
Oh,
Okay, we'll tell you, just can you? It's question 70.
7.6.
Yes. I can tell you.
Okay, please, yeah.
Integration.
So we have integration, yes, please.
Sec 2y.
Second,
Equal to-
okay, 2y.
No, power.
Second square. Secant square y, okay.
dy
dy.
over root
Square
1 minus
1 minus.
tan power 2y.
Okay. So definitely these things are not very clear. Here we need substitution. Okay. So what you have to take as u, please?
But we take all minus
Just only take agent y, please, as you. Okay. So who's free derivative?
Second.
Secant square y dy is equal to d. Now come back here. I have secant square y dy. It's very how much? D. And then we have square root and 1 minus 10 is u. It has square. Now open the formula sheet. Which formula is matched?
tan just
So that's it. So you have now, this is sine inverse u over a is 1. U means tangent y. And plus c because there is no limit.
I shot the thought that I wanted to make
No problem.
Yeah.
Good. You have done well. Get the idea up? Right. So this is the situation. Let's start now, please, chapter 8, is 8.1, please, 8.1. There is no new topic. 8.1 is a review of all the integration techniques which you have done until now.
Sir,
Please.
I have a question. Not watching the,
How much difference?
it's my answer is this, as that answer is, well, things. First, I think this is, first, I will.
Okay, we can try. Let's give it. Integration?
Yes.
Okay.
From 2 over to 2 is 9g. Then 5 secant square.
5 times.
Yeah, secant square and angle is secant inverse.
X.
Over, yes, over x times square root x squared minus 1.
Okay. This is also one of the question 7.6, please. So here we need also substitution. What we take as u? Secant inverse. So start this. Secant inverse x is equal to u. Now we need secant inverse derivative, and you have the formula sheet, please.
Yeah, it's 1.
So you can see, please. What is that?
It's 1 over absolute value of x
1 over absolute value of x
times x times square root of x squared minus 1.
minus 1 and times x derivative which is only 1. Okay, and of course it is dx
Yes.
and u is d. Okay.
Because it's supposed to be.
Yeah. Now the x behavior you can see from here. 2 over root 3 until 2, the x is positive. So you can remove this absolute value. Now look at it, please. Do you have this whole stuff in your question? Look at it. Dx, and then we have x, and then we have this one. All this is equal to how much? Du. So now this is integrate. 5 you can take outside. Secant square, and this is basically u, and dx by this is du. Right. What is secant square integration? Then, so we have now this is 5 and this is tangent u. My u you can see, my u is secant inverse x. So u is secant inverse x, and we have limit from where to where? 2 over square root 3 until 2. Okay. Now substitute please upper in the answer. So this is 5 times tangent with the angle secant inverse 2, am I right? Minus again 5 times tangent with angle secant inverse and value is
High answer.
2 over square root 3. Right.
You can change it from sign.
So actually, if you go directly, definitely, I have done this question last class, if you remember. I told you how you can calculate the examples. So it should be cosine inverse with 1 over 2. So please tell me 5, then you have here tangent. How much value you are getting?
Pi over 3.
Sorry?
Pi over 3.
Pi over 3, okay. Minus 5 times, then you have tangent function here,
Pi over 6.
5 or 6.
Yes.
Okay. Now, what is tan pi by 3?
Radical 3.
So this is 5, and you told me this is radical 3. Okay. Be careful means there should be radian, okay?
Yeah.
And minus 5. What's tan pi by 6?
Radical 3 over 3.
Radical 3 over
3.
3. Okay. Now you can make the common denominator, please. So here we can multiply 3 and up also 3, please. Or it's okay, means no need for that. Means you can use calc, it's fine. What is 5 root 3 over 3 minus 5? Come on, sorry, means not here. This one. Just use calculation answer. How much?
10 over 3.
10 regular 3 or 3?
Yes.
Okay. That's it. Understand?
Yeah, just time.
How you understand? Yes, please. Yes, please. Previous question?
So we can just make it bigger. Take pictures.
By the way, this is very important question. Means where we need first substitution and then we go back to the rules. Very important. Okay. It is 7.6. In 7.6, basically, you have initially you have means direct formulas questions. Then you have quadratic square, and then you have this one. One I missed. One topic I missed in 7.6. Do you know? Huh? No, 7.6. 7.6, which is inverse dramatic function. If you practice the questions, do you observe that one topic we missed in 7.6? Yesterday I was making the exam paper, so I thought I did not discuss this question. I can study and we can study and we can include.
No need.
I can show first. Means which topic specifically I'm talking about. So let me open the 7.6 section, please, for you reference. So 7.6 section, which I'm talking about, these are basically here 81 to 84. Sorry, not 84. 81 and 82. Yes. 81 and 82.
Yes.
No, sorry, even not 82.
Okay.
No, sorry, yes. 81 and 82, exactly.
That will
Yes, sir.
What is that?
Long
Huh? Yes. Here we need first long degree. Because look at the degree of numerator. In 81 question, what is the degree of numerator?
3,
No, 81.
2,
2 and down,
2,
degree are same. And 82 question,
3 over
up, degree is more than down. These two situations are not allowed to use, the rules which we have done. Upper degree must be less than down. Then you can use that tan inverse or secant inverse or sine inverse. So first of all, 81, for that 81, you have to first of all make it long division. Then the up degree is reduced, and then you can use your procedure. Thing like here. Okay, so this concept also we have to apply. So means here, first of all, in 81 question, please use log variant. X squared plus 2x minus 1 and x squared plus 9. So of course means you have to multiply one once. So what is that? X squared and 1 times 9 is 9. Change the sign, please. So this is gone. What we have now? 2x and minus 10. Now write your long deviant answer. Means your question will convert to this form. Question not change, only the shape change, the format change. Question not change, please. How you write the long deviant answer? So this is basically, yes,
One.
yeah, quotient plus you have Bhakti divide by x squared plus 9. You know how to write the long deviant answer? Quotient plus remainder over divisor. Q plus R over D. This is the rule. Now, this is the question number 81. So you need its integration now.
Question of one.
It's a quantity x. And here now you will use that, which is basically a square plus 3 square means which rule? A square, constant square plus function square. Tan inverse. Tangent inverse. So here you have to use that, please.
But
Is that in the exam?
Sorry. No, you have to split first, yes. Because up is function, you cannot do. So please, we have one more step. Let me write this question separately, please. So I'm talking about the question number 81, please, where we need, first of all, long deviant. So, which is here, 81 question, please. First of all, we use long deviant. The question becomes 1 plus 2x minus 10 divided by x square and plus 9. Okay? Understand my point? Okay. Now integrate. Distribute, please. 1 times dx and now plus integration 2x minus 10 divided by x square plus 9 and dx. Okay. This is okay, no problem. What is the x integration? X. This is fine. Here's a good x. Here we have again problem. We cannot integrate at all right now, please, because we cannot use here the inverse. No. Look at the formula sheet. Open the formula sheet, please. In the formula, up is only 1. 1 for any constant, please. Right now, you have 2x. Oh, yes. If it is only 10 constant, then it's fine. You can use that formula. Right now, variable is up. So you cannot use the inverse formula directly. No. What we do?
So can we take you as the x square?
Yes.
X square as you.
No.
2x over x.
Again, what is the derivative of down? 2x. What is up? 2x minus 10. Not matching. No. What do you do, please? We will split.
Yeah.
We will split. You understand what I did here?
Yes.
I break 2x over this minus 10 over this. I hope you understand. Oh yes, now things are easy to evaluate. So here you will use substitution, yes. So what you take as you please? X squared plus 9, exactly, means here, let x squared plus 9 is equal to u. So 2x dx is equal to d. So this 2x becomes du, which is x plus integrate du over x squared plus 9 is du. Minus 10 you can take outside. Oh yes, now what is that? Dx over x squared plus 3. What is that? Now it's tan inverse. So which is 1 over a tangent inverse x over a. And plus c. I think there is no limits. So plus c. I'm sorry, not plus c. I still have pending integration. So not now plus c. make this one also. So this is x plus du by u how much?
Then
ln, and u is which value? U.
X.
X square plus 9. Yes, so absolute value x square plus 9 minus 10 over, sorry, 10 by 3. 10 over 3 tangent inverse x over 3 and plus c. I hope you understand.
So this question is coming in the exam.
It's okay. Means this is basically I'm just giving you the idea. The two questions here you need first long degree.
But you're not present?
Yeah, actually I have done the exam paper, so I don't want to change. Yes, so. Question please.
I just want to know, this.
This one? I write the answer on long division. Use long with this.
So we don't have to study. It's always,
Yes, yes. The rule, look at it, please. I will give you the rule of long division. Whenever you have long division, this is the rule. Look at it. Quotient plus remainder divide by divisor. This is the rule. So quotient is here up. This is quotient 1 plus you have the remainder 2x minus 10 and divide by divisor. So this is the basic rule. Quotient plus remainder divide by divisor.
doctor, we don't have to study.
It's okay because I forget. That's why.
So it will come in the exam. You remove it.
I forget to insert the question because I forget this. Anyway, so do you understand the logic behind it? Okay, because I was surprising maybe if you start 81, 82, so maybe you say how we answer the question. But I shared with you the procedure. Do you understand, please?
Sir, I will please repeat from where we got the 1/3 tan inverse.
1/.
It was written there that tan multiplied by 1/3 tan inverse.
In the answer, please. Okay. Right. So basically here, this is my a square. Sorry. Means a means 9. You can write 3. If you go for the formula sheet, it is 1/8 tangent inverse u over a.
Yes.
So now my a is 3. So that's why I have here 3. Then I have here also 3. And my u is basically s. Is good now?
Yeah.
Good. Yeah, please, come on. Any more question, please?
Doctor, you said that the tangent will be put on and had some like hoops, not with like u square is greater than.
No, that is hyperbolic, please. Don't mess up, please. Should be things very clear, huh? That's for hyperbolic here. Come on, you have formula sheet and still you're not getting involved. If you have not formula sheet, imagine what happened. So please, be careful, okay? Means when you in exam, when you match the question and formula sheet, please be careful, okay? Because in some formulas, only minus is a change. For example, in sine inverse function, it is a square minus u square, okay? And in sine hyperbolic inverse is a square plus. So only one thing is changed. No doubt, it is confusing. I know it's confusing, but please, I'm repeating again and again, please, that be careful when you select the formula. Please select the correct formula. Okay, now?
Yes, sir.
Good. Okay, let's start, please. Please. As I told you, please, in chapter 8, 8.1 is only the review of all the integration techniques which we have done already. Nothing new thing in 8.1. It's a review of all the integration techniques because chapter 8 is only for integration techniques. So we done new technique in chapter 8. 8.1, because that's why they said as a review, they said, okay, these techniques you have done already. So they just list down in 8.1 all the old techniques which we have used already until chapter 7, they just included in 8.1. So because there is nothing new in 8.1, so no need to start 8.1. Start with 8.8. Exercise number 8.2. Okay. Chapter 8 is totally based on integration. And this is exam 2, please. Exam 2, chapter is 8. Okay. You know, okay. In 8.2, we have to learn a new technique. Everybody know the names of that technique? Integration by parts. Exactly. So integration by part we have discussed today. We will make integration by parts, please. By part. Okay. I'm sure many of you already have done this topic. You know the rule as well. However, I have my own rule, which I developed my own. So I will share my rule here, please. If you like this rule or if it is easy for you, you can adopt it. Otherwise, the technique which you already know, you can use that one, no problems. Because both are same, by the way. Okay, you know, integration by parts, what is the biggest problem we solved by this problem, by this technique?
Integrating two functions.
Yes, it's something like if you have product of two functions, you can integrate. But there was a big problem. Means there's a function we cannot integrate before this technique. This technique make possible.
And
Yes, good. Natural log function. In chapter 7 or before, we have never integrated LNX. Do you integrate LNX? Good son. As an answer, we got LNX. Means, for example, if you have du over u, so the answer is ln absolute value of u is okay. But we did not integrate LNX directly. No, because it was not possible. Now, first time we integrate LNX by integration by parts. Okay? Right. There is one more function whose integration was not possible before that. Yes, very good. Inverse functions. Absolutely right. There's no integration of inverse functions before that. Yes. First time you will see we will integrate also inverse functions. Okay? Yes, nice. Means that you have already discussed study before. Nice, good. Now, first of all, I will share the formula for that. By the way, please, in chapter 8, now, chapter 7, there is no formula sheet available in the exam, okay? Please, sir. Now, first of all, please look at here. Note down the formula of by parts. How by parts we what? We always take by parts question, let it is capital I. Capital I, please. Whenever you start by parts question, please. So before you apply by parts formula, first of all, say let my question is equal to capital I. Okay. Why? I will show the reason behind that. Don't worry. Okay, start now, please. Okay, I think first of all, I should give the format. Integrate. Basically, this is the format of the by parts. Means you have product of two functions. I say first function and second function. In the book, they just give UV, same like derivative of product two, but it's not the derivative; it is integration. Okay, so please, yes, my question is I. Okay, now please start. The formula which I developed is like something like that. First function. Okay, no change as it is. Integration of second, then minus sign, integration, and then integration of second again. Means whatever answer you get from here, please, just copy paste here. Means no need to find again the integration, this one. This part we have done here, just write the answer here, please. Okay? So first function, no change, multiply. Second function, integration, minus sign of integration, second function integration times the derivative of first function. This is by parts formula. In the book, this slightly different. So if you are familiar, if you are working previously on that formula, please don't change. Please don't change. This is only for your reference, please. I will follow this one. So if you think this is easy or okay, so you can adopt. Otherwise, the formula which you know already, please work on that. Because at the end, you get same answer. So no worries, please. Okay? Right. Now, what is the biggest, complication here? Basically, here, whenever you apply by parts, we should know which function we take as first, which function we take as second. Because question comes as a product of two functions. They not tell you.
Which one? The one that is easier to integrate, you take it as.
Yeah, so generally, if you look at the formula here, generally it is very clear, take that that function as second, whose integration is
Easy.
possible and easy, yes. Don't take a function whose integration not possible, you're stuck here.
There's a rule that tells you to use which one.
Yes, I will share you, yes, okay. Sure, I'll share it. So, okay, generally please, we take that function as second function whose integration is possible or easy to calculate. Because look at here, in the formula, we need integration of second function. That's fine, okay? And there is a shortcut technique. It's not any, formula of math, no. The instructors or the students, they devise this shortcut by their experience. With experience and with practice, they have come up with some shortcut who can decide you who is first function, who is second function. So you can take help from that shortcut as well. That shortcut is same like, if you remember, when we discussed that trigonometric function, we make all students take calculus, yes or no?
Yes.
So it's not a formula mathematical, no. Just an observation of the students or the instructors. They develop this thing because it really works. It means in first quadrant, all functions are positive. In second quadrant, only sign positive, and third quadrant, tangent positive, and in fourth quadrant, cosine. So similarly, means with this, observation, they develop a shortcut piece to decide that which function we can take as first, which function we can take as second. By the way, this is not 100% correct, please, okay? Sometimes no need to follow this shortcut. Anyway, you can note down. This said, follow this statement. I-L-A-D, lit, I-lit. These are the abbreviations of the functions. I mean inverse functions. Means follow the order. If in your question you have inverse function and for example, okay, first I explain what are they representing. I mean basically inverse. So one thing is confirmed. If in your question you have inverse function, they will take it always as first. Okay, I first discuss first and last. Okay, E what? Exponential, exactly. Exponential. So one thing is confirmed, as per the order, exponential functions always second, and inverse function always, because the hierarchy is more. Okay, now L is representing what? Oh yes, logarithms, exactly. Okay. A is representing algebraic function. Algebraic function means polynomial, x square root, x power 3. Okay, these are algebraic things. D means what? Trigonometric. Yes, trigonometric things. Now, for example, in your question, You have log function and trigonometric function. Which function should be first?
Log.
Yeah, because L comes first. So log will take first. Trigonometric becomes second. So from this order, you have to decide. But again, I'm telling you, it's not any formula, please. It's just an observation. Maybe it becomes wrong sometimes, okay?
So you can't
But
depend-
roughly you can get the,
so you can't depend on it for each question.
yeah, you can't depend, yes. No. You can't depend.
So what do you do?
But it works. Mostly it works, yeah. Okay? Right, so I have just shared with you that which function you can take as first, which function you can take as second. Generally, what is the idea? Take that function as second whose integration is possible or easy to calculate. Because when you apply this rule, you need second function integration. Okay? Good. Let's start now. As I told you that basically this technique by parts enable the integration of LNX, please. Exactly, I don't know the example number in the book, but it's okay, it's fine. I just take an example, please.
So the Doctor will continue solving in this way.
Yes, yes,
Oh.
of course. Okay, now integrate LNX dx. Now we have to integrate natural log function, and I told you.
One time.
Okay, she told me this is example number 2 from the book. Okay, thank you very much. Example. Now, as I told you, means by parts integration now enable us to integrate LNX. But by parts need two functions. I have in my question only one LNX.
Break it down.
Like one.
So how I write this LNX, please?
You break it down.
Yes. Okay. First of all, please, as I told you, and make it habit for you. Whenever we start the by parts question, say let my question is capital I. Okay. And the next please. And as I told you, I need two functions as a product. So I can write this LNX as LNX and 1. Can I write LNX in this way?
Yes.
Because LNX line 1 is same LNX, okay? But now I have two functions. First, okay, I have two functions. Now, please tell me which function you take as 1 and which take you take as second.
One.
And then I'll start first, and the second is
1 is basically which function, which category?
algebra.
Ah, yes. 1 comes algebraic function. So you can see if you have log function and algebraic function, so log comes first, yes. So log is first function, algebraic is second. Okay, good. So this is my first function, please. And this is my second function. I hope you understand. Now just put this values in the rule. That's it. So if you apply the rule, what the rule says, first function copy paste. What is that?
And then,
Very good. Integration of second function, which is 1.
yeah,
Minus sign of integration, integration of second, multiply the derivative of first. Understand the point?
yeah.
And please, you need at the end dx. Why? Because this dx is for what? For this integral, yes. Okay, please continue.
Doctor, up you want two integer.
Sorry.
Go back to the rule also.
Oh, yes, yes, yes. Sign of integration. Sign of integration and integration of dx. Yes, yes, you're right, you're right. Absolutely correct. Absolutely correct. Okay, thank you very much. Now we have evaluate integration and differentiation, please. So this is LNX as it is done. What is dx integration?
Yes.
Right, very good. Minus sign of integration. I told you this is basically repeating from here.
So that's.
Is answer how much? Just copy paste here x, please. No need for that. No more, please. Okay. What is derivative of LNX?
1
Very nice. And at the end, you have dx because of this integral sign. Okay. And now we have here x LNX minus integration of dx. How much? X and plus c because it is indefinite. I hope you understand. This is the by parts answer.
Can make it bigger.
So this is called integration by parts, and I just started with the example or integration of natural log function, please, because first time we are integrating that. Before we did not integrate.
So whenever we have only one function, we will multiply by one.
Ah, yes, exactly. If you are sure this question should be answered by parts. And yes, there are many functions where you can make one exact. Any question right now?
No, but
Why is it equal to I?
Okay.
Use it.
Integration.
I will take one example, so I will explain why you have to take by parts question as I. Okay? This is really, really important. Can anybody answer this question? Why I'm taking, when I start my question by parts, I take my question as I.
Sometimes.
Sometimes you use the question first, that's all. So.
Okay, any other?
We have.
No, so what was the reason behind that? Why?
You the equation itself as the integral of del x, you write it as I.
So if I don't use I, then what happens?
What do you solve?
That times why this keeps repeating.
Basically, sometimes the question of by parts goes in a loop. Same thing coming again, no end. So to stop this loop, we use this technique. So I will take one example, then inshallah you understand very well. Okay? All right. You have that book, please, okay, because I need one more example. No. It's EX percent. Right. Which example number, please?
For
4, okay. Example number 4, please. Example 4. Example 4, please. Okay. The question is that integrate.
e of x. Cosine x dx.
Okay. Right. Now, this is the question, and you can see here we have two different functions. One of them is exponential, the other is trigonometric. We decided already. Exponential is always last, second, because in isolate statement, E is at the last. So this is your first function, this is your second, and this is first. Now, as I told you, please, when you start the question of by parts, please let my question is equal to capital I, okay? Now, please start. First function, integration of second function, please. Minus sign of integration of second, please. And times the derivative of first function, which is how much cosine. By the way, actually you can go directly. No need to first, write in the rule and then calculate derivative or integration. You can start directly. No issue. Save time if you can. Okay. Now cosine x. What is ex integration? Oh yeah, it is same. Good. Minus sign integration. Just copy paste this one. Ex times. What is cosine derivative? Negative sign. So please put here sign and put here plus because I have negative sign with the cosine derivative, right? That's why this sign changed. Because cosine derivative is negative sign, negative. I already have negative outside, so I make it positive. Is okay?
We apply it again. Integration
Of
by part.
course, we have with no other option. Okay, so now here we have here ex cosine x, please. Plus, okay, how I integrate this one? Again, two functions are multiplying. So again by parts. Again by parts, please. Okay, so start. First function. Again, I mean ex is second, okay? First function, integration of second function. Minus sign of integration of second, and derivative of first. Derivative of sine x, please. And your dn dx. Okay. So now, EX cosine x, copy as it is, plus sine x. EX integration, you know very well, EX minus integration, again it is EX. What is sine derivative? Oh, cosine x and dx.
This is equal to I.
So again by parts, right? Again by parts because you do functions. So now the problem is that this question never ends. The loop.
How does an I make it stop?
Look at it now. This side we have already I. Now EX cosine x, please. Plus EX sine x. And minus, look at here. Do you know EX cosine x in the starting, what I told you? It is equal to what? So do not integrate again because we are in a loop. Just put EX cosine x here in the value how much? I. So look at this. This is basically equal to I. This is equal to I.
At the end, I will write I.
Of course, otherwise again you need by parts.
So-
Never ends.
You stop when you reach the question is answered.
Yes, you have to check means can I have the real question? So that question is I.
It's where you stop.
Yeah, but not stop now. Please, we have to continue. Once I shift this side. I plus I have already one I. It comes here, becomes what?
2I.
Oh, yes, I.
Then divide by 2, right?
Oh, yes, very nice. We need only I. This is the integration by part answer. Capital I represent by parts answer. I don't need to. What should I?
Why?
That's it.
But this is the true answer.
Sorry?
This is not the true answer, right? And we should continue, right?
Oh, no, never end. It comes again. This question is in a loop. You have to break the loop, please. That's why we need this I technique. Yes, please.
What if we stop getting the noise to,
How do you understand it?
like I equal, then we write I. I mean,
You don't know. This question is the loop, this question is not. We have no idea unless and you start the bypass.
so we have to make a second, to make sure that.
Of course, otherwise, how you know that this question has loop? So capital I is equal. Now you can take something is over here. EX again is called factor, or you can write this two as well. And then we have cosine x
Plus sign up.
plus sine x. And plus C also because there's no limit.
Do you have to take contract?
Yeah, it's okay. Make the simplified form.
Can I figure out the third?
Okay, it's sure. So now do you understand how we have, why we have to take this I? Otherwise, there's some questions where you get a loop. To break the loop, you have to put I, and then you can, transfer, collect both the I's. So sometimes you get two I's, sometimes you get 3 by 4 I's, whatever you get here, we need only I's, whatever here, divide those sides. Means we need only I, given I comes. Right.
So doctor, every time would be like, we put I, then we shut them.
If, yes, exactly. If you are getting in your solution, you are getting again question, so replace by I.
When I reach the question.
Yes, if you read the question.
I put I, then shut them, divide.
Exactly.
Factor.
Yes. Okay? Right. Can you share me one example? Let me check it. Examples like that. And then next one is. Just. Meaning what's right?
But.
You're out of Sorry.
For integration by parts, can you solve all the integration you took by it? Or do you have to use substitution sometimes before starting?
Yes, we have to use substitution as well, exactly, but because by parts integration is also very lengthy, and if you go back to substitution inside, sometimes become mess. So what we do, in the starting, we can take substitution, and then we start by parts, okay? or, there are some questions where I will tell you shortcuts directly. So that during the 5 parts calculation, no need to use substitution because it takes much time. So just wait, I share some question where I will tell you that write the answer directly without substitution. Otherwise, the question of 5 part becomes very. Okay, so just stay with me. I will share different, situations. Okay, question 12. Integrate
Right, yes.
tan inverse 1.
Sorry.
Is sine inverse? Okay, who was tan inverse? 11?
No. Yes, 11.
11 is tan inverse? Okay. Make 11. Tan inverse y d. I told you already, two functions were there who were never ever possible before to integrate directly. Lnx and inverse. And this bypass enables us to integrate. Okay. Now the inverse function. What is the hierarchy order?
First is the first.
Is a first, but I need two. So I can write tan inverse as tan inverse times 1. Okay. Because we need two functions.
Always apply.
So first of all, this is my capital I. Then I write my question as 1 multiply tan inverse y and dy. Okay.
Apply one and you only have one function.
Actually, bypass need two. In the formula, we have first function, integer second function. If you don't have second function, you can apply.
Why do you mind the function?
What? Because bypass need two functions. Bypass needs two functions.
Why do you put it first?
If any change, one times tan or tan time one different.
Yeah, there's about.
No. I'm asking, can I write tan inverse in that form?
Oh, yeah.
Is okay? Now you have to decide because when you apply the formula rule, in that rule you should know who is my first function and who is my second. Okay, and yes, as we discussed already, inverse is always first function. So please start now. So first function, which is tan inverse y, am I right?
Yes.
Integration of dy because it's 1. Okay, minus sign integration again into dy times the derivative of tan inverse y. And here, please, my dear students, sorry. No formula sheet. You have to memorize all the inverse trigonometric functions derivatives. Otherwise, you stuck in the exam.
What was this?
Yes. Memorize.
If you got them the first exam, why can't you get them?
Because we have just quoting in first exam that you have to go back and revise and now memorize. You only need inverse functions derivative. That's it. Not more than that. Only one table in exam. Otherwise, for example, if I put this question exam, if you don't know how to get the derivative in inverse, you cannot answer the question at all.
No, it's a good.
No. Only the trigonometric inverse trigonometric function derivative and some integration also. I will mention, don't worry. I mentioned to you which rules you have to memorize for exam 2. Don't worry, I have to mention, okay? Dy is y minus integration dy is y times, yes, come on. What is the formula of inverse tan derivative?
1 over
1
plus y
plus
squared.
1 plus u square times u derivative, which is 1, and dy. Okay, please, for the sake of exam 2, you have memorized inverse trigonometric functions derivative, please. Okay, now rearrange y tan inverse y.
Only for exam 2.
Only for exam. Yeah. And now, please rewrite this one. I have y divided by 1 plus y square and dy. Okay, please integrate this one.
Do you use any?
Oh, please be careful. The substitution, yes. 1 plus u square, sorry, y square is u. So 2y dy is equal to du. I have in my question only and only y dy, right?
Yes.
So I don't need to.
Make
What?
du over what?
So y dy is basically equal du divided by.
The one.
So this one, y dy value how much? Du divide by 2.
Make two outside.
So y tangent inverse y minus integrate, this is du, divide by 1 plus y square is u. Now tell me how much du by u? No, it's,
Sir, where is the two?
sorry, 1 by 2, yes.
When did you
Sorry, please. I should look at it. 1 plus y square is u. So 1 plus y square derivative 2y dy. Okay.
why do you
So du by 2 is constant, take outside. 1 over 2. Now y tan inverse y minus 1 by 2 and then absolute value of u. What is u? 1 plus
1 by 5 squared.
y square with absolute value and plus c. This is my bypass integration answer. Okay. Sometimes please, no need for the absolute values because the function itself positive. For example, right now, look at here. You know, why put the argument absolute value? Because if argument become negative, ln become undefined. Right now, y has square and square means always positive. So y square never ever gives you negative answer. And this is one is already positive. So sometimes means if you look at the answer in the back of the book, they do not apply here absolute value. Why? Because we are 100% sure 1 plus y square answer never ever become negative. Make sense?
It's the same thing.
Sorry.
It's the same thing. And you want to deduct marks if we instead of silly bunch.
No, I will not. But I'm just giving you the way. I mean, sometimes if you take the answer from the back of the book and you're not in the homework, you're not find the absolute value, then you think what is absolute value? Because this argument is itself positive. No, it not required absolute value. That's why. Okay, and that's why. So inshallah, we have a lot of situations in this five parts. Different, scenarios are there. Okay, we can go for break and then
Can you make it bigger?
these are some initial things, please.
Okay, good job.
I'm thinking means how much I have to go because the next class gets start 8.3.
Sponsored for 8.7.
No. There are 2, 3 more variants. Are there.
So we won't be able to finish 8.7.
Yeah, that's what I'm thinking means next time means I have 4 more different concepts here. So
Next class.
yes, but in next I want to finish the 8.3. Anyway, shall we see what?
Until when is the this?
National